Hi everyone, welcome to Mr. Wagon's math class again. We already learned about inequality that has a maximum or a minimum value. We already learned how to write the inequality, solve the inequality, and graph the inequality. For today's lesson, I wanted you to think about an inequality that has both minimum and maximum. For example, the highway speed limit. You guys are going to start driving soon. If you drive too slow, you get a ticket. If you drive too fast, you also get a ticket. So there's a minimum and a maximum. For example, the first one, the speed limit is no more than 70 miles per hour and not less than 45 miles per hour. So there is a minimum and a maximum speed limit. In different countries, they measure speed limit with kilometer. Here's another example. You guys are going to start working soon and making the big bucks. When you start working, you have to clock in and clock out to see how many times or the number of hours you worked. What if your boss told you you can take 15 minutes break and leave 15 minutes early? Is it the same as when he tells you you can take 15 minutes break or leave 15 minutes early? Are those two the same? Remember, it's your legal right to take 15 minutes break, so your pay is not going to get affected if you take 15 minutes break. Now, the difference is, and you can think about this too many different ways. The first one is maybe you have 30 minutes less work for the day, or you only have 15 minutes less work of that day. Also, I can think about this first one with the and. That means you can do both. You can take the break and leave early. So you're doing both events. With the second one, you can only do one of them, not both. And this will take us to today's lesson. Think about an inequality that has both minimum and maximum value, both minimum or maximum value. Compound inequalities are formed by joining two inequalities with the word and or the word or. So when you have minimum and maximum or minimum or maximum, those called compound inequality. So the word or the word and mean two different things in math. So how can we write, solve, and graph compound inequalities? The graph of a compound inequality with and is the intersection of the graphs of the inequalities. The graph shows numbers that are solutions of both inequality. So when you use the word and, it's an intersection and it solves both. The graph of a compound inequality with or is the union of the graphs of the inequalities. The graph shows numbers that are solutions of either inequality. So when you use or, it's a union and it shows the solution for either or. Here's an example, writing graph compound inequalities. A number x is greater than -8 and less than or equal to 4. I will color code this for you to see. The green one, a number x is greater than -8, so that's the first of the compound inequality. And circle and. In the blue one, less than or equal to 4, which is the second part of the inequality. Now, x more than -8 and x less or equal than 4. And when you have a compound inequality with and, you can write it as one equation or one inequality. So you can erase the word and, put x in the middle, but make sure to start with the least number first from the left because we read from left to right. So make sure you have the least number on the left side of the inequality. Now to graph it, bring your graph. How do you graph the first side? X more than -8. There is no equal sign, which means -8 is not a solution. So use an open circle on -8. And now I need all numbers more than -8, so I go to the right. But remember, there's a minimum and a maximum, so there's a limit for this one, which means it starts here, ends here. Go to the right. Now, I need to graph the second part, which is the blue one. 4 is a solution, so I will use a closed circle. Put the closed circle on the 4. Now I need all numbers less than 4, so I'm going to Watch how they both intersected. Watch how they both sides are shaded, and it's from -8 to +4. So the solution of this inequality is between -8 and +4, but -8 is not a solution. That's why it's called an intersection when you have and, because the solution actually intersects. Here's another example to work with. Write and graph compound inequality. A number y is at most 0 or at least 2. Again, it's color coded. The first part is in green. Circle or to make sure it is an or. And then the second part in blue. Is at most means a maximum. At least means minimum. So I know which sign to use or which symbol of inequality to use. If it's a maximum, then I'll use less than or equal. If it's a minimum, then it's more than or equal. So y less than or equal to 0 or y more than or equal to 2. And I have to write the word or because the solution will not solve both. It only solves one side, either side. And let's see what that means when we graph it. So bring the graph. Let's graph the green part first, y less than or equal to 0. Since 0 is the solution, so I'll close circle, put it on the 0. I need all possible solution less than 0, so my arrow goes to the left. Now let's graph the second part, which is y more than or equal to 2. Since 2 is the solution, I need a closed circle, put it on the 2, and now I need all possible solution more than 2, so my arrow will go to the right. Notice how they did not intersect. The solution of the green arrow would only solve this equation, and the solutions of the blue arrow will solve the second part of the inequality only. That's why it's either. So this is called a union, and the arrow shows this set of solution for either inequality. Check your work by using a number that is not in the solution set. 1. 1 is not a solution. In substitute 1 instead of y. Is 1 less or equal to 0? No, so 1 is not a solution to the green part. Now, what about 1 more than or equal to 2? Is that a true statement? 1 is less than, not more than 2. So this is not a true statement, which means it's not a solution. Now, how can we solve compound inequalities? Remember, when you have an inequality written as a less than x less than b, the conjunction is always and, because you can write it as one inequality. -3 less than -2k minus 5 less than 7. Watch how we start with the least number first from the left. Always when you write compound inequality with conjunction and, you always start with the least number. So isolate k. I need k by itself. Use inverse operations. The only thing you need to pay attention to, that whatever operation you use, you have to use it to all three sides of the inequality, left, middle, and right. To get rid of the 5, use the addition property of inequality to the left, middle, and right. So add 5 to all sides of the inequality. You end up with 2 less than -2k less than 12. Now I need to get rid of -2 to leave k alone. Since it's a coefficient or a negative coefficient, I need to divide by -2. Remember, when you divide in by a negative number, you need to reverse the symbol. Keep that in mind. So division property of inequality, when c less than 0, reverse the symbol. Divide each side by -2, and you end up with -1 more than k more than -6. Is it written in the right way? No. So rewrite it where the least number is from the left. So read it this way. -6 less than k and k less than -1. Now how do we graph that? Bring your graph. Again, since it's a compound with conjunction of and, then there is a shaded area or there is an intersection of the solution. Now how can we solve compound inequality with the word or? Always with the word or, solve each inequality separately. So 4c plus 3 less than or equal to -5, or c minus 8 more than -1. I will put a line under the or because I need to solve each part separately. So let's start with the left side. For c plus 3 less or equal than -5, I need to isolate c. Which number is 3? Is the 3. Since I'm adding 3, use the subtraction property of inequality. So subtract 3 from both sides. You end up with 4c less than or equal to -8. Now I'm dividing with 4 both sides. Use the division property of inequality. Remember, if c more than 0, that means you are dividing by positive numbers. Symbol stays the same, so don't change it. You end up with c less than or equal to -4. Now, let's move on to the next part by itself. C minus 8 more than -1. Use the addition property of inequality, so add 8 to both sides. You end up with c more than 7. How do you graph it? Put the number line. Let's start with the blue or the left side first because you have to graph each one separately. Since -4 is a solution, use a closed circle on -4, and I need all possible solutions less than -4, so all numbers less than -4 are a solution to that part of the equation. Now to graph the second part of the equation with the red, that means 7 is not a solution, so we use open circle on the 7, and I need all possible solutions more than 7, so I will be going to the right, showing all possible solutions to that part of the equation. So this arrow shows the solution to this part only. The blue arrow shows the solution to the left part only, so either, not both. Okay, now real world problem. We almost everybody have cell phone nowadays. And you know if you leave it in cold temperature, it will not work. Or if you leave it in very hot temperature, also it won't work. So for the device to work, it has a minimum and a maximum temperature. Otherwise, it won't. So look at this example. Here's the phone, and its operating temperature is 0 Celsius to 35 Celsius. They wanted you to write and solve a compound inequality that represents the possible operation temperature in degrees Fahrenheit of the smartphone. So did you notice something? This is Celsius and they want it in Fahrenheit. Make sure you do that. So look for your clues. Here's a phone. What are you trying to find? The degrees in Fahrenheit. And that's the F or the variable we will give to this equation. Clue number 2, do I have a minimum and maximum to know which symbol to use? Yes, it has a minimum of 0, so I use more than or equal, and it has a maximum of 35, so I use less than or equal. Now, which equation would you use to convert to Fahrenheit? It's 5/9 parentheses F minus 32. So now let's write the inequality. 0 less than or equal to 5/9 times F minus 32 less or equal to 35. See how the equation in the middle? It's between 0 and 35. Should be more than 0 and less than 35. Now solve for F. I need F by itself on one side of the equation. What do I do first? Multiply 3 sides by the reciprocal to get rid of the 5/9. And the reciprocal is flip the fraction. So if it's 5/9, flip it, it'll be 9/5. And make sure you multiply the left, middle, and right side of the equation. Now, 9/5 times 0 is 0. 9/5 times 5/9, they cancel each other. You end up with F minus 32. Bring the less and equal down. 35 times 9 divided by 5. Multiply 35 times 9 is 315 divided by 5. Now simplify that, and you end up with 0 less than or equal to F minus 32 less or equal to 63. Now I need to isolate F. That means I need to get rid of the 32, the addition property of inequality, add to all 3 sides. You end up with 32 less or equal to F less or equal to 95. So the range for that cell phone to work, it has to be between 32 and 95 degrees Fahrenheit. Otherwise, it won't work. That's it for today's lesson. You guys have a great day.